All right, so back to more examples, even, odd, neither, and also related to symmetry. If it's symmetric around the y-axis, there's symmetry y-axis, then we got an even function. If there's symmetry around the origin, then we have an odd function. Okay, so let's take a look. What's this one? Same process, f of negative x. If that equals f of x, it's even. If it equals negative f of x, it's odd. And if it's neither, it's neither. So let's take a look. Negative x quantity to the fifth minus 3 times negative x. This part I know is a little weird, but if I multiply negative x by itself 5 times, I get x to the fifth, and it would be negative, because there'd be 5 negative 1s in front of there if you want. And then this one would be negative 3 times a negative x. That's a plus 3x. And then can you see that that's just a negative 1 times your original function? Or you can always try and factor out a negative 1, and that makes it x to the fifth minus 3x. And then look what we have here. This is f of x, my original function. And it's minus. So I end up with a negative f of x. And that means it's odd. Odd and symmetric around the origin. How about this guy? Do the same thing. Is this going to be odd? My guess is it's odd because of an odd power. So we know this is going to be, right, the same thing happens, negative 2x cubed. But look, we get a minus 7. That kind of messes up the symmetry there, or the odd property. If I factor out a negative, I get 2x cubed plus 7, which is not negative f of x, right? Because f of x should be 2x cubed minus 7. So that guy's neither. How about this one? Is f of, my guess is, if anything, it's going to be even, but I got to do the math. Remember, to do the math, I plug in a negative value for x and see what I get. So that's 2. It's nice to show your work. You might not need this step because you know that negative x squared is the same as x squared, right? If no matter what goes in here, when I square it, it's going to be positive. So it's just going to always be x squared. But if we're trying to do, this is kind of like a mathematical proof. We're trying to show that this is even, odd, or neither. So I like to show my steps. So I plug that in, and I know negative x to the fourth is the same as x to the fourth. And the negative x squared is the same as x squared. And look what I get. Same thing. That's f of x. That is even. Let's see if I can show you this on, if I can look at these functions in Desmos real quick. All right, so let me look at the calculator because it's easy to see on the graph, right? So if I graph that last function, see if I can determine by graphing that it's an even function. So that's 2x to the fourth, 3x squared minus 5. Let me bring in Desmos here. Bear with me 1 second. So it's negative, or I'm sorry, 2x to the fourth, 2x to the fourth, plus 3x squared minus 5, plus 3x squared minus 5. Okay, can you see the symmetry there? Right, it's a reflection around the y-axis. A lot easier on the graph, but we can check our work that way. All right, let's look at that other one. That was, so x to the fifth minus 3x. See if we can see the odd symmetry there, which is a little bit harder to see. X to the fifth minus 3x. So can you see the symmetry around the origin? If I were to kind of guy and wrap it around 180, this would be up here and this would be down here, right? If you just kind of twisted that thing 180 degrees, the graph would be the same graph. All right, so I hope that's helpful. And that's my last example for that section.